So now what we're going to do is we're going to go ahead and add that pair-event spectrogram analysis to our NexScript so that we can analyze continuous data. And so that we can look at this analysis on its own without having to run the pair-event rasters analysis every time, I'm going to go ahead and comment those lines of code out using the %sign. So as we learned with our pair-event rasters, that the first thing we need to do is select the correct data. So in our NexScript, the neurons are currently selected, and we need to select the continuous data. So first we're going to deselect all in the open document. Now unfortunately there's not a select all continuous data function. So what I'm going to have to do is write a loop that will tell the NexScript to sequentially go through and select each of my continuous variables. Looking at our NeuroExplorer file, they're named FP01 through FP08. However, FP01 is continuous variable 1 since it's in the first row. Row 30 is going to be continuous variable 2. And FP02 could actually be named FP89. It doesn't matter because it's in that second position of the continuous variable. And so what I need my NexScript to do is go through and select 8 continuous variables. So let's go ahead and write that. So it's going to be for C number equal to 1 to 8. So what I'm doing here is assigning the variable C number the numbers that I want to go through and select. It's always a good practice to close your loop before you write code in between it. So I'm going to go ahead and use the select variable function. You can see here what I need to enter. The first is that it's going to be acting on the open document. The number, so is this number 1, is this variable number 2, is this variable number 3, and we wanted to go variables 1 to 8, so we're going to put C number. And then the variable type is continuous. Now to make sure that this loop is going to do what we think it's going to do, we're going to save and run this file, and we should see in the NeuroExplorer data file that the neurons become unselected and the continuous data becomes selected. And that is what we see. Now our continuous data is selected and available to run through our analysis. So let's go ahead and run that template. So that's an active document. And perispectrogram is the name of the template, but not the full name of the analysis. So now we're going to go ahead and run this analysis to see what it looks like. So what we have here is on the y-axis frequency by time on the x-axis. And the color indicates the spectral density. Now these don't look great to me. I'm not really seeing anything meaningful. So now I'm going to go back and set the parameters that I need for my data. And because I've done this before and I know my data, I'm going to actually set 10 different parameters. So I'm going to actually go ahead and copy and paste this. So the first parameter I'm going to set is that reference again. And again, I'm going to use that getName doc.tcstart function within my modified template function so that it'll pull the tcstart event directly from the NeuroExplorer file itself. Then I want it to start at -1 seconds. So the analysis window is going to start -1 second before that time 0 of TC start. Now this analysis doesn't have a traditional end analysis window. Instead, the analysis window is set by the number of shifts and the length of these shifts in seconds. So I'm going to go ahead and do 30 time shift windows. Make sure I put quotes around that. And I'm going to make these shifts length of 0.025 seconds. Another parameter I want to set is the number of frequency values. I think of this as the y-axis resolution. So if I only have, say, 50 as my number of frequency values, or right now it's set to 64, for each time shift window, I only have 64 frequency values. And because I have my show frequency from to show frequency to values set from 0 to 200, I only have 64 frequency points spanning that entire range of frequency values. So if you look at the number of frequency values, this is a drop-down menu, and you have to select one of these choices, and they're based on the digitization frequency of your data, and so you might not see numbers like 1,000. But I like to choose a moderate number. I'm going to go with 1,024. And so now I will have 1,024 data points on my y-axis for each time shift value. I like to normalize my data. Right now, it is a raw data. I'm going to do a decibel log normalization. And again, you can see your options by looking at your drop-down menu under your properties. I'm also going to set those show frequency from and show frequency to values that I talked about. So I'm going to set this Y range from 0 to 80 instead of from 0 to 200 as it is set right now. Finally, I want to apply a smoothing filter, and right now it actually is doing the filter I want. It's doing a Gauss filter with a smoothing width of 4. But I'm going to write this into my properties just in case somebody else might come in and change it, and I want to make sure that my data is being run correctly when I run this NexScript. And notice I am being very careful to make sure everything is exactly the same as it is in the properties. Otherwise, you're going to get errors when you try to run the script. So now let's save it. Let's see if I get any of those errors and see what the peri-event spectrograms look like after all these settings have been modified. Oh, and I did get an error, and that is because I left off a parentheses. So then we have to save it again. And these look much better to me now. I have a much better range on my y-axis. I can actually see things happening. It looks like I have something happening here around 50 hertz. And I also have that nice 60 hertz noise that I'm going to have to filter out. And so now that I'm happy with these data and the parameters I've set, I'm going to go ahead and save these data or these graphs to PowerPoint. And this is very similar to what we did with the send results to Excel for the peri-event rasters. And again, you see all the different things that you have to set for this function. So it's again going to be on the data in the open document and the presentation path with the name. So I'm going to go ahead and copy the path. So it'll be in the same folder as my test data. Make sure you put quotes around this. And instead of test data, as I've named it up here, I'm going to call this test graphs. And again, it's going to make a PowerPoint called test graphs. The next parameter I have to input is the slide title. And then comments. This might be if there's an experimental comment you want to add or something like that. And then the last option is add parameters. This is a true false, and yes, I want to print the parameters to the file. That's going to print all these different properties onto the slide itself. So in case in 6 months, I can go back and know what parameters I used for that analysis. So let's go ahead and run it. And once it's done, we should be able to pull up the PowerPoint. And here we have a slide. There's a slide title, here's our parameters, here's the graphs that we created. Any comments would go down here. And then down here is the data file that produced these graphs. You can see this is NexScript test file 03, which here is the name of our data file in NeuroExplorer. You can see the name of this PowerPoint is test graphs.